Hello, here is our project to visualize data structures. For my part, I will tell you about the linked list. And before we jump right to the linked list, I just want to show you that when you hover the mouse over on the data structure, there will be a line of color that is like running around the bounds of the rectangles. So yeah, let's just get into the linked list home menu. So first of all, here is the home button that is used to get back to the home menu. Here is the undo button to get back to the previous state. And this is redo. We get back to the state before we clicking undo and reset to clear all the linked list, all the history that we have stored, and yeah, basically that is on the button here. And we get to here. The first one is init, that is the short form of initialization. When we click on that, there will be like a linked list that is created randomly by just adding nodes to it. And I also insert like a limit so that it can be shown like all the nodes on the screen. And for this one, I'll let it by the size is 40. Next one, we clear this one. We have the add button. So here we can add a node to the root. For example, like we add 5. Here's what's happening. Like you can see, when we go here, we get back to the first one, there is nothing. And then when we click on here, we get to the current state, I would say. So basically there is two steps. And here is like the animation progress of the functions, I would say. When you click here, it can get to the previous state that I have already stored. And we can also use this button too. This is like fast forward, fast backward. This is like forward, and this is like backward. And what else we have here? This is for reset. Like because we are in this one, we need to get out. You can click anywhere on the screen, or you can click this one to get back to the normal program. Okay, so and because this one I already let the user to add the new node to the root or to the end, like to the tail of the linked list. So the same thing happened for the tail. We just get back to state to ensure that we have inserted correctly. Okay, and as you can see here, this is another button that is allow us to choose from a file. Okay, so I'll have click on a file. For example, I want to insert from 1 to 6, and because I will let the user know that they have to insert 0 at the end of the linked list to ensure that there is that linked list has the end, so I can insert to the current linked list correctly. As you can see, a new linked list has been implemented. So it's from 1 to 6 as I said. So yeah, this is for the add functions or insert function. Now we move on to the search function. So in the search function, it's just used to look for a node, whether it is like in the linked list or not. For example, we look for the node 74. It will traverse through all the nodes to check if there is 74 in the linked list. And yes, here we need to click on the screen one time to get to the animation step. We get back in state to check if it is okay. Click here and here and here, here and here. So yeah, that is correct now. And we uh, we need to find something that is not in the linked list as well. For example, 100. Oh, and I set 100 to is the maximum like value that you can input to the linked list, and I didn't allow users to input negative as well, just for the beauty of the linked list. So here you can see that no there is no node that is 100, so the value couldn't be found. We just get back to state to check if that is okay, and we click here to reset it. What else? Then we delete. First I want to delete 54. We have the process here, and we need to wait until the value found step or the highlights, it is highlighted, then we can click to make it flying on the screen. Okay, we just get back to state to check. So as you can see, we have already deleted. Now we will try to delete the root node. Here, that is the root node. So I'll click on delete and 5. So value found, we click again to keep it in the delete progression or progress. Yeah. Okay, we check if it's correct. You may want to look at here. We have value found as the as the result of the checking, and we have the current node as well. I mean, that is just like 2 steps, but it is the same linked list, so you can see that there is no difference. So we have checked, and yeah, it has been removed. Now we go to the update function. This function is used to I would say to update a node by insert its position first. For example, we want to update the node at the position 6. This is 1 and 2, 3, 4, 5, 6. This is 6. So I want to insert it as the 6th ray, and this one is 100. And because I have set up that we have to insert at the position first, and then we click on the keyboard to make the function start. We search for the 6th node and then wait until this one is checked, and we click on the screen to update the node. You can see that in just a second it has been moved to here, and it's like delete, but there is no like flying steps in update function, so that is a bit quickly. We get back to state just to check if that is okay. Okay, and we can see that the functions has updated the 6th node. So now here is the additional functions that I have added to this project. First one is the undo. Here, this is 100. We click back. Here is the node 1 at the 6th position. We redo it. Here is the 100. And we also changed the rate of updating the linked list. For example, I just maybe I just have the current speed, right? You can see here, and then when I add something in, you can see that is a bit slower. For example, 9. You can see that it is much slower compared to the other state, but that is still correct. And that's all. After you have finished everything, or you just want to have a fresh start, you click here. That will delete everything and prepare a new state for a linked list. So basically that is all what I have in linked list visualizer. So we will continue with other part.
Okay, next, let me introduce to you the hash table visualizer. Here we will enter to the hash table mode to come to the hash table. First, we have to enter the style of the hash table from the keyboard here. For example, I will enter 45 and then press enter. Then a hash table with 45 nodes has appeared. Now I want to initial value into the table. There are two ways to initial a hash table. First, I can click to the add buttons and upload from file. Before upload from file, I will prepare an input TSD. For example, I will insert into the table for values 45, 67, 78, 90, and then save the file. Now I will click to the upload from file. The window will appear and I will choose the input TSD that I have saved before. Open it and the for value will be inserted into the hash table. Another way to insert the value in a hash table is use the init button. When I click to this button, the value will be randomly filled into the nodes of the hash table. Again, I will initial with random values. Now, I will introduce to you the insert operation. Click to the add buttons and then here at the keyboard, we will insert a value to table. I will insert 24 and press enter. Here you can see the animation will run and then an announcement here announce that the 24 is inserted into the 26 index node. At the right corner, you can see here is a procedural code to explain what it is run here. Now move to the search operation. Choose the file button here, and then for example, I will search 24. Press enter. The animation will run, and here is the procedural code of the search. Next, I will introduce to you the delete operation. I will delete 24. You can see the animation here will run and the residual code is corresponding to the animation here. The announcements, yeah. Come back to the add. Come back to the insert operation. If you want to insert it and observe it step by step, you will press C. To change the mode from run at once to the step by step. Now I will, for example, I will insert 16. Enter. Here the announcement said that press right for the next step and space to skip or to finish or the operation. I will press right. Here is the start index. Yeah, press right. The animation is run corresponding to the pseudo code. Then when I find an empty index table, I insert the 16 in. In the file, in the search operation, it has the step-by-step mode too. For example, I will search for 16. Yeah, press right to do the step by step. Yeah, and we found 16. For example, delete operation, we have delete 16, then enter, right, press right, and I want to skip all of this animation. I will press space. Yeah, and then number 16 is selected. Now I will change the mode to the run at once again. Press the C and the mode is changed to run at once. Here, click to the right button. I have the button to change the speed of the animation. For example, I think the speed is too slow. So I will make it faster by spread it 2.5. The speed is set to more 2.5. Now do the insert operation. For example, I will insert 16 again. And as you can see, the animation is faster. For example, another example, for example, I will click it to the set the speed to x 0.75. I will search for 16. As you can see, the operation is very slow. Yeah, so that you can observe it clearly with the procedural code on the right corner. The next, for example, I will delete 16. The animation is very slow, so I can observe it clearly that the 16 will be deleted when it found here. Now, I introduce you to this undo buttons. Click here. Click here and the hash table will move to the previous hash table. For example, the 16 will be a 16 again, and the redo, it will do the redo. The 16 will be deleted when I click the redo, and the last one is the reset. Click it and the table hash table will reset everything. Yeah.
This is demo video for try graph data structure. Firstly, we move to try. A try will support A features. I will test one by one. The first one is init. This will randomly add random string to the try. And insert. We support insert from keyboard and also upload from file. For example, I will set the string, and as this is supported basically for the current operation, and also run step by step. Yeah, you see. Um, next is the search operation like this. Yeah, it's also support step by step, and also the issue. Delete. Yes. Yes, and also the step by step, and this is undo and redo feature. If you delete the wrong thing, you can undo the last step if you want, and also redo the last. Yeah. And so you can change the speed of the animation. Yeah. You see the difference. And update and add update feature. You need to choose a file and the program will print out on the string in the try to that file, and you make change in that file. When you finish, you just click OK, and the program will update according to your change, like this. And clear features that delete the whole tree. Also the undo and redo history. Next, we move to the graph data structure. In graph, the algorithm we choose is Dijkstra, and we support for both undirected and directed graph. And at init will support two things. Init random from the keyboard and also a program file. For example, I will random, yeah, and run Dijkstra. And it's also had below at this region. And during the animation, you can also change the speed of animation. Yeah. And when the dash line finishes, it will have the animation to draw again the path from the nodes you choose, and also provide the step-by-step run step by step. Also, you can upload from file. Just choose a file in the format that the first line is the total node, and on the next line you have to input two integer OVW. That is the two nodes and the weight of that node. Right here. Yes. Yeah. And also we support for the directed graph. And this button is when you don't want the node move, you can click and it will stop the node from moving. Yeah. Here we choose random. Yes. And you can run step by step. And that's the end of